Yes, what are you doing now? Yeah.
So first you have to, as I told, switch on the X-ray.
Okay.
X-ray is on.
Yeah.
Yeah.
Okay.
No, it's fine. No, it's not started.
Okay.
And now you are using it without any low angle kit. I showed you this low angle kit, you remember?
Yes. Yes.
So we
Okay.
are not using any low angle kit.
Yes.
So we have to start from 10 degrees here.
Where is that? Here?
Yeah, 2 theta. So this is the start value that you want to give 10 degrees.
Okay.
And 90 degrees fine if you want to measure till 90 degree. This is what you should be careful. If you are using the low angle kit, you can go up to 5 degree. If you are not using the low angle kit, you start from 10 degrees. You don't want to destroy the detector.
Okay.
And give the time. First make a very fast scan, so 0.1 maybe.
Okay.
No, here, this time.
Okay. Okay.
Yeah, no,
Okay.
you can give 0.1 for example.
Okay.
And then you can increase. Click here.
Step.
Yeah. And now click here. Yeah, so it's
Total time.
seconds you need to do it. And now you can put start.
Start.
Yeah.
Now start.
Yeah.
Okay.
If your sample is crystalline, it will diffract. If it is amorphous, it will not diffract.
Yeah, of course.
That's the basic.
Okay. This one is also XRD.
Yeah.
Uh,
Powder, and it is non-ambient. You can do low temperature and high temperature.
uh-huh. When you measure my sample, low temperature, high temperature.
You can
Check.
also do low
This-
temperature, high temperature. But for this, you have to first qualify as a user in this machine,
Uh-huh.
and then we move on to D8 Discover, and we can show you the training and
For other training, I need.
yeah.
Okay.
Yeah. See the background, the primary beam. This is the direct beam coming from the X-ray source to the detector.
Detector.
And when you are going to the low angle, this beam, this is actually coming from a very high.
Okay.
Yeah. So from 10 degrees, it's already 600. So from 5 degrees, it might be 5,000. And then if you expose the detector too much, detector will burn. That
Okay.
is why when you are going to low angle, less than 10 degrees, we are always using that kit.
Okay.
Yeah.
Okay.
Now you see there is a
Oh.
peak that you have.
Okay. Oops.
It's a very good sample. I mean, I think that it's not exactly pure because you have to analyze. I can show you later on how to analyze. Yeah. So you are successful in preparing something. Congratulations, Dr. Hassan.
Yes. No, no.
So you are working in Turkey before this?
Yes, in Turkey. As assistant professor, but
Oh.
all the time I am. Most of the time I do teaching.
So you had a permanent job over there,
Yes.
and you left it?
Yes.
Oh my God.
No, not left it. Just a permission.
So you took a leave.
Yeah.
For how long?
Now 6 months. Maybe I'll extend it.
Okay. And you will not be paid during this time, or you will also get payment. Oh, that's very good. You are very lucky.
But if I extend it, I can. I won't get.
Ah,
Now it's 6 months. It's okay.
okay.
But after that,
Oh,
if you get much,
so you are very motivated.
yes, of course.
Yes.
I think all the universities. I don't know exactly the other country on Turkey is give permission 1 year, 2 year sometimes.
It's very good. I love Turkey. I think there is one of my junior. She has gone for postdoc
Mm-hmm.
in a Turkish university. I forgot the name of the university, but
Bilkent.
maybe.
Oh,
Yeah.
uh-huh.
How is the salary good over there for postdoc?
I don't think so, but no, not as
Don't talk about cows, but
Yes.
like Europe.
No. Less.
But people are going from India to Turkey. That means they must be doing good research.
Yeah.
Otherwise, why should you go
Yes.
to Turkey?
Yes. But life is cheap. Turkey,
Ah, yeah.
very cheap.
Yes.
Also, in Turkey, if you get 5,000 like Saudi, Saudi
Saat.
saat, almost same. Turkish lira saat is same.
Okay.
It's enough. You live as a king.
But you want to also now convert yourself to euro, right? You
Yeah.
want to enter the eurozone. There is a
Not yet. Eurozone, but yeah,
you want, right? That
Yes.
Turkey wants.
yes.
No, last year approximately is 22.
Mm-hmm.
So 700, but in order to have a good diffraction pattern,
Mm-hmm.
and your sample is so less, that's one problem. But still, we use the zero background holder,
Mm-hmm.
and your peak, you don't have a peak here.
Mm-hmm.
So maybe you can start from 15 degrees,
Mm-hmm.
yeah, so that you don't have a very huge. So
Yes.
you can start from 15 degrees.
Mm-hmm.
and
Okay,
from-
again.
Yeah, and from 15 degrees, you see that background is only 100.
Mm-hmm.
So, and you have 700, so maybe a good signal to noise ratio or signal to noise, it should be like more than 3000. Is always
3,000.
better, yeah.
Ah, okay.
So if it is more than 3000, now you have 700. So it will be 4 times.
Mm-hmm.
You need to increase the time. Last day when I was explaining you that if you want to get a good profile, you always have to increase time, right?
Mm-hmm.
Yeah. So maybe you can make it 5 times. 0.5, yeah.
Okay. Okay.
Click on the steps over here. So you need half an hour to measure it.
Half an hour.
Yeah.
Oh, okay.
You don't have time?
Yes, I have
You have till 5 o'clock, right?
Yes, yes.
I have slotted for you. Yeah.
Okay.
So, and, for example, this is how you judge when
Okay.
you see the pattern, that you don't have any peak at low angle,
Mm-hmm.
but maybe you have this peak.
Mm-hmm.
So why not measure from 15 to get rid of this primary beam?
Okay.
So go here, you can start from 15. Yeah,
Mhm.
and 90 I think is okay because you have a peak at
Okay.
86.
Okay.
And you also have to judge. You can zoom your peak. You see the K alpha and K alpha 2 line also. It's very good sample actually. The quality of your sample is very good. So
Yes.
zoom, reset, left click, right click, yeah.
Okay.
Yeah. So I think the resolution is okay because you are getting K alpha 1, K alpha 2 lines.
Mm-hmm.
So you don't have to decrease the increment.
Mm-hmm.
You understood, right? This is 0.02 degree.
Mm-hmm.
So every step you are going like 0.02, 0.02, you are increasing like this.
Mm-hmm.
You are going 0.02 degree, exposing for 0.5 second.
Mhm.
Again 0.02 degree, 0.5 second.
Mhm.
This is the strategy of measurement.
Okay.
Alright? So, since you have already a good resolution, I think we don't need to
Change thing.
change it. Yeah. Later on, after doing this measurement, we can see whether we want to get a better resolution.
Okay.
Alright, Mr. Hasan?
Okay.
So, let's start.
Okay.
15 to 90, it will take Now we'll open this program. This is called diffrac.eva.
Okay.
Yeah. The EVA program. It takes some time to actually initialize. File. So you import.
Mm-hmm.
And
My
in the Somnath, it will support, yeah.
yes.
File.
Okay.
You see
Yes.
your diffraction pattern.
Yeah.
And it has automatically calculated. If you look carefully,
Mm-hmm.
you see it has automatically calculated a kind of background.
Now, okay.
You see?
Mm-hmm. Background.
It's not background, actually how I would call baseline.
Baseline.
Yeah,
Baseline
because the background
is the
is like changing, right?
Yeah.
It is like this, it is zigzag.
yes.
But it somehow has smoothened and created a baseline.
Mm-hmm.
So this is how you do search, match, scan.
Mm-hmm.
And a window opens over here.
Mm-hmm.
So first you have to rebuild.
What's that?
Rebuild over
Okay.
here.
Rebuild. Okay.
Yeah.
Rebuild.
Yeah. So you can also do like auto,
Mm-hmm.
or you can for the whole you can do select whole range, or you can select sub range.
Mm-hmm.
So for
What
sub
is-
range, for example, if you want to cut some peaks,
Ah, okay.
right now we have 15
Mm-hmm.
to 90, right?
Mm-hmm.
If you want to analyze only from 30
Yeah.
to 40, so you can do that.
Okay.
But we will do the whole range
Oh,
right
yes.
now,
Yes.
yeah. And we can do it auto, or we can also do it simple pattern, complex pattern, or neutral pattern. It's up to you.
Okay.
Yeah. But let's do auto at the beginning.
Mm-hmm.
Yeah. And then you can go to the database filter. But this is like default. You have lot of options. You can this when you are doing yourself, you can go through. I'm just showing you how to do it. Yeah.
Mm-hmm.
So there are a lot of options which you can explore.
Mm-hmm.
Candidate list, selected candidates. We have not yet searched.
Mm-hmm.
Another one is that you can do a chemical filter.
Mm-hmm.
So what chemical do you have here?
This one?
Yeah.
Okay. Cesium.
Where is cesium? I'm very bad in periodic table. Where is cesium?
What is this cesium? I don't. Yes, this is cesium.
Cesium.
Yes.
So this is at least one. You see, this red is discarded, blue is at least one, and green is mandatory. That means you should have these chemicals. So you can either do this, or if you don't want, you can also not do this filter. But we will do the filter. So
Okay.
cesium and
Cesium, silver.
silver is Ag. If
Ag.
I am correct.
AG. Yes. Order.
Somewhere here. No, I cannot find Ag.
Yes, me too. What is the age?
Ag.
Yeah.
And?
AG. And just a minute. Cesium, AG, antimony.
Antimony, what is SB, right?
Yes.
SB.
Yes, antimony and what is that? Bromur. Yes, brom.
Bromine.
Yes, bromur.
Bromine should be in group number 7.
Yes.
So bromine.
Yes, bromine.
Okay. So we have done the filter, yeah.
Okay.
And now we go
Okay.
to candidate list again, yeah.
Okay.
And here is the search.
Mm-hmm.
Click.
Where is it? Click?
I clicked on
Ah.
search.
Okay. Sorry.
It's trying to match from the database. There are so many options.
What does it mean?
Yeah, that means like So here you get
Yes, it's cubic is
yeah.
crystal signature.
yeah. So you have it's a cubic system.
Uh-huh.
You know it's cubic.
Yes, I know.
How do you know? You said this is not published.
No. I checked it.
So it is similar.
Yes, cubic.
Okay.
Yes.
So you see, this is
Uh-huh.
bromine cesium.
Mm-hmm.
This structure is close to 4.286. Here you have close to 4.286. But you see that this is the calculated one. This is the database, right? And this is your actual pattern. So it is a bit shifted
Yeah.
because this is only cesium and bromine.
Okay.
But you have one more thing, which is silver.
Yes.
So the structure is similar, and you have very similar lattice parameter. So your A is 4.286. So B is also 4.826, and alpha, beta, gamma, 90, 90, 90. Yeah.